In this lesson, we'll deal with conditional probability. Let's outline independent events and dependent events before we start. The previous section on probability trees dealt with independent events. What this means is that what happens in one event does not affect the outcome in following events. And we can look at this example using a coin. So when you toss a coin, you'll remember you can get either a head or a tail. This is your first event, E1. Your second event is what comes on the second coin, either a head or a tail, head or a tail. And remember that these probabilities are half each. So if it's a half for the first event, the second event is also a half. That means that these events are independent. So what you get on the second coin does not depend on what you got on the first coin. They're independent. So in independent events, these numbers will be the same. So for example, if we had a half probability of a tail, your second coin is also a half because they're independent events. So we can outline a little bit of information here. We'll clean that one off. Okay, so actually what this outlines is actually a part of a tree. So look at the first probability of getting your first head is a half. I'm not going to worry about the tail because we're not interested in those. The probability of two heads in a row, so your first one is a head, your second coin is also a head. So the probability of two heads is a quarter, a half times a half. If we continue our tree and you want to know the probability of three heads, it would be a half times a half times a half, and that's 1/8. So the probability of getting n heads in a row is a half to power n. So you could think about what's the probability of getting 12 heads in a row. That would be a half to power 12, which is a very small number. So if you're playing a game, your chance of getting 12 heads in a row is going to be basically almost impossible. Not zero, but very close to it. And this is called the multiplication law for independent events. And you can see the multiplications are being used here. So a half times a half times a half and so on. So that's called the multiplication law of independent events. Now today we're going to deal with conditional probability, and that's related to dependent events. Dependent events are affected by previous events. The main example we will see is when you have balls of different colors in the bag. You take a ball out from the bag, you note the color, but now you don't put the ball back. In the previous lesson with probability trees, you were replacing the ball, if you remember. But in this time, we're not going to put the ball back. So this means that the probability will change when the next ball is taken out. So let's look at our example here. You've got, in your bag, you've got 5 balls, 2 blue and 3 red. So imagine now that you take a red ball out, then what is left in the bag? There are 2 blues and 2 reds now. So your probability of getting a red on the second time is 2 out of 4. But in the first event, it was 2 out of 5. Okay, so notice that these two numbers have now changed. In this instance, when you take out a blue ball, your probability of a blue is 2 out of 5. And then the probability of the red now is going to become, well, your probability of blue is actually 1 in 4. Okay, so your probability of a blue here is 2 in 4, and your probability of a blue now is 1 in 4. And we note how the probability has changed. Okay, so we'll do a more example to clarify that. So let's look at our example here. We'll fill it all in. So we've got a bag that contains 2 blue balls, 3 red balls. One ball is drawn at random and its colour is noted. The ball is not put back in the bag. A second ball is then drawn from the bag, not bad, and its colour is noted. We complete the diagram below. When we've done a diagram, then we can answer these questions here. So if we look at our diagram, okay, so these are your 5 balls. When you take out a blue ball, there's only one blue ball left, isn't there? So now the probability of getting a blue ball is going to be 1 out of 4. But the red ball wasn't touched, was it? So now we still have 3 balls in the bag, but there's only 4 balls. So now this probability becomes 3 on 4. Okay, and so your probability of 2 blue balls is going to be 1 on 10 here. So 2/5 times 1/4. So now we take out the blue ball again. So we're going to get 2/5 here. Take out a blue ball, and then how many red balls are in the bag? There's 3 red balls now. Okay, so now your probability of getting a red ball is 3 out of 4. Okay, and that's going to give you 6 out of 20, which is 3 out of 10. So when you've got, in this case, now we still have the 5 balls, we take out a red ball. Well, your probability of a red is 3 on 5 first, to start with that. And then you take out a red ball, 3/5. So now, what is your probability of taking out a blue ball? You took out a red ball, so now there's only 2 red balls and there's 4 balls in total here. So your chance of taking out a blue now is going to be 2 out of 4. 2 out of 4. Okay, so that's 6 out of 20, which is 3 out of 10 again. So in this case, the last one, your chance of a red ball is 3/5 times taking out a red ball. And now what's the chance of getting another red ball? There's only 2 red balls out of 4. So it's 2 out of 4. So it's going to be 6 out of 20 as well, which is 3 out of 10. Okay, so from that diagram, we've got 1/10, 3/10, 3/10, 3/10. When you add them up, you'll get 10/10. So we know we've done the question correctly, because the sum of these probabilities should add up to 1, which it does. Okay. This last diagram here shows that when you take out the last blue ball, there'll only be 3 red balls left. And if, in this case, if you take out another red ball, there will be 2 red balls. So for our question here, we're actually not using this set here. That's the next step if you were to continue the tree. Okay, it will go on and on and on until all the balls have gone out. Okay, so from this diagram, we can go back and look at our questions. So what's the probability that both balls are red? If we look at our diagram, well, we should actually label it, shouldn't we? So this is going to be blue, blue. This is blue, red. This is red, blue. This is red, red. So the probability that both balls are red is the last one, red, red. So that's 3 on 10. That both balls are the same colour, part B. So the same colour is either red, red or blue, blue. So red, red was 3 on 10 and blue, blue is 1 on 10. Which will give you 4 on 10, which is 2 out of 5. Okay, part C, both the balls are different colours. So which of these are different? The different pairings are blue, red or red, blue, and we add those two values. So that's 3 on 10 plus 3 on 10. So that will give us 6 on 10, which is 3/5. Okay, part D, at least one blue ball is drawn. At least one blue ball means, let's use a highlighter. At least one blue ball here, blue, red, red, blue, or blue, blue. You can have two, that's no problem. At least one blue ball means minimum one blue ball. So that's going to be 3 on 10 plus 3 on 10 plus 1 on 10, which will be 7 on 10 here for that example. Okay, what's next? Okay, so in this example, in some cases you don't actually need the probability tree. Okay, so in this case, imagine there's a lottery where you need to get 5 correct balls from 40, numbered 1 to 40. Each ball drawn is not put back. What is the probability you will win the lottery? Okay, so you've got all these balls in the bag, 40 balls, and you need to take out 5 correct balls. Okay, so your chance of getting the first ball right is going to be 5 out of 40, isn't it? Because there's 5 balls available and there are 40 in total. So your chance of getting the first one correct is 5 on 40. The chance of getting the second one correct is going to be 4 on 49. 39 actually, 4 and 39. So that's the chance of getting 2 balls correct. Notice how the numbers decrease together. You've taken out 1 correct ball, okay. Now there are 4 balls left that you need to get, and there are 39 balls left because the ball's not put back. Okay, and as you can see, we continue that until all the balls have been taken out from the bag. So your probability is going to win is going to be 1 on 658,008. As a decimal, it's very small. So that's why in the lottery you're very unlikely to win. Okay, if we were going to do a tree, we'd have the first ball is 5 on 40, the second ball correct, 4 on 39, the third ball 3 on 38, and so on, 37, 1 on 36. And these are all the other balls, but we don't need them because we only want the winning balls, and these are them there. So in this kind of question, you don't really need to draw a tree. Okay, you can start the exercises, but we can have a look at this first question. Okay, we've got a bag, which is similar to the first question. A bag contains 3 pink balls and 2 blue balls. 1 ball was taken out at random and not replaced. A second ball is then taken out. Complete the probability tree and then determine the probability that, okay, each of those questions. So we've got 3 pink out of 5, 2 blue out of 5. Okay, what I do first is I do the pink pink and I do the blue blue. So if you take out a pink and don't put it back, there's only going to be 2 pink balls left, isn't there? So your 3 will become 2. But because you've taken the ball out, there would only be 4 balls left. Okay, so your probability of pink pink is going to be 3 on 5 times 2 on 4. 6 on 20, which is 3 on 10 for that one. That should be 3 on 10 as well, I just noticed that. Okay, and then I could do the blue blue. So take out a blue, you will only have 1 left, won't you? So if you've taken the blue ball out, the chance of the next blue is going to be 1 on 4. So your probability of blue blue is going to be 2 on 5 times 1 on 4. 2 on 20, 1 on 10. Okay, and for the blue pink, if you've taken out a blue ball, there's only going to be 4 blue balls left, isn't there? That's this one here. But there are still 3 pink balls in the bag. That's why this is 3. One quick way you can think about doing this is look at the relationship of the numbers. Notice how these are 5s. Every other number, because the ball is not replaced, will be 4. Okay, these 2 will be 4. And also notice that this number 2 is here, and this number 3 is here. That's another way to think about it. If you want to get the correct answer, you can just move these 2 numbers across. Okay, 3 on 5 becomes 2 on 4. 2 on 5 becomes 1 on 4. And then these 2 numbers can be crossed over. So this one, last one, probability of a blue than a pink would be 2 on 5 times 3 on 4. 6 on 20, which is 3 on 10. Okay, I'll let you answer these yourself just from using that diagram. Okay, have a go yourself, see how you go.